Hello and welcome to another Math with Miss V video. We will be looking at graphing inequalities, specifically how to graph them on a number line that is only one direction. So first, let's talk about graphing equations and refresh our memory that equation is a number sentence with an equal sign. So this is a very basic equation where x equals 4, and we would graph that by having a dot and putting it on the number line where 4 is to show that our answer is 4 and only 4. As a review, what is an inequality? As we saw in the one-step inequalities video, which will be linked in the description below, an inequality is a number sentence where two sides are not equal to each other. One side has a higher value, and we use the following symbols to show that: less than or equal to, greater than, and greater than or equal to. So there's two things we have to think about when we graph. What kind of dot do I use, and how do I know? And which direction do I shade in, and how do I know? And in the next two slides, we will look at how we decide and why is there a choice in this. So there are two different types of dots we use when we graph inequalities. We have the choice between the open dot and the closed dot. So the open dot is simply a circle, and it's used when the number of the variable when the number the variable is being compared to does not make a true statement when substituted in. Now that sounds a little confusing, but let's just look at these examples. So we have x is less than 5. So we want to substitute our 5 in for x so that we have 5 less than 5. Well, this is not a true statement. 5 is not less than 5. So when we are ready to graph, we would use an open dot. Our other example, m greater than -3. So we would replace m with -3 and end up with -3, excuse me, is greater than -3, which is also Our next example is m greater than -3, and we would replace the m with -3 and have -3 is greater than -3, and we can see this is not a true statement. So we would use, when we're graphing, the open dot. Next would be the closed dot, and the closed dot is just a colored in circle. And the closed dot is used when the number the variable is being compared to does make a true statement when substituted in. So we have b is less than or equal to -1. We would replace the b with -1 and read our inequality. We have -1 is less than or equal to -1. This is a true statement. -1 is not less than, but it does fall in the or equal to section. So we would use the closed dot, which is a circle filled in. Our next example is y is greater than or equal to 4. We're going to replace the y with 4. Is 4 greater than or equal to 4? Yes, 4 is not greater than 4, but 4 falls under the or equal to section. So we would again use the closed in dot when we're ready to graph. The other thing you might notice is that our less than and our greater than always use the open dot. If they have or equal to, they'll use the closed dot. So which direction can we shade? As inequalities have more than one answer, we have to shade the number line to show all possible answers. So the first option is to shade to the left, and we shade to the left when the inequality has a less than or equal to. This is only true if the variable is on the left side of the inequality. We shade to the right when the inequality is greater than or equal to. Again, this is only true if the variable is on the left side of the inequality. The next screen is one of my favorites. This is my overview of inequalities, or my cheat chart. And this shows us just all of our different types of inequalities. It shows what type of dot is used, and it shows which direction we graph in. So if it is a less than, we use an open dot and we shade to the left. If it's greater than, we use an open dot and we shade to the right. Less than or equal to uses a closed dot and shades to the left. And greater than or equal to uses the closed dot and shades to the right. I encourage you to take a screenshot of this and use it as a reference to help you out on all of your inequality activities. Now we're going to move into completing examples. These have already been solved. If you need a review of how to solve, again, the 1-step and the 2-step is linked below. Okay, so we're just simply graphing these. We're drawing a number line. Now, a lot of number lines you will see will have a ton of numbers on them. The bare minimum, which is what I prefer, has 3. The number in your inequality, 1 number smaller, and 1 number larger. I use the direct smaller number and the next larger number. You can use any of the 3. Okay, so we look, we say x is less than 5. So is 5 less than 5? No, that's not a true statement. So we're going to use our open dot. We need the less than numbers. 4 is less than 5, so we shade to the left. Okay, next one. We draw our number line. I'm going to put -6 in the middle. Remember that my negative numbers are reversed, so -7 is smaller than -6, and -5 is greater. Okay, we replace m with -6. Is -6 greater than or equal to -6? And it is, so we're going to put a closed dot on -6. We need my greater than numbers. Greater than is always to the right. -5 is greater than -6, so we will shade to the right. Now, you don't have to shade the full length of your number line. Just have to shade to at least 1 number. Because I only use 3 numbers, I always shade to my other arrow. Okay, our next, there we go, that's better, is b is greater than 2. So let's put in our numbers. 2, 1 smaller is 1, larger 3. Is 2 greater than 2? That is a false statement, so I'm going to put an open circle. I need everything greater than 2. 3's the side that's greater, so I'm going to shade to the right. Next example. F is less than or equal to 3. Let's put in our numbers. 3, 1 smaller, 2, 1 larger, 4. Okay, is 3 less than or equal to 3? And it is. 3 is equal to 3, so we will use our closed dot, and then we will shade to the left. We want the numbers smaller, less than 3. Okay, we're going to look at a few more examples. My first one, P is greater than or equal to -6. And I'm just going to skip ahead and draw all of these number lines so I don't have to keep going back and forth. Okay, so let's put in our numbers. -6, 1 smaller would be -7, 1 larger, -5. Is 6 greater than or equal to -6? And it is equal to, so we're going to use our closed dot. We want our greater than numbers, and we're going to shade to the right. The next one, U is less than 15. So I'll put 15 in the middle. One smaller, 14. One larger, 16. Is 15 less than 15? That is not a true statement, so I'm going to use my open dot. My less than numbers would be towards the 14, so I'm going to shade in that direction. Okay, next example. Negative 17 is less than or equal to W. Okay, this is one that is written backwards. Okay, the W is not on the left-hand side. We can graph it the same way, but it takes more thought. Okay, negative 17, it's less than or equal to negative 17. Yes, that's a true statement. Okay, negative 17 is less than or equal to W. So which direction are we going to shade? Well, generally less than says shade to the left, but if we replace is negative 17 less than or equal to negative 18, that's not a true statement. So we need to shade to the right. And this is why I encourage you, if you see them written backwards, to reverse your inequality. So swap the W and the negative 17. It's open towards the W. It'll still be open towards the W. Now we have W is greater than or equal to negative 17, and we can see that is true. Our last one, I'm going ahead and filling in my numbers, but again, I see 3 is greater than H. This is backwards to make graphing easy. So let's swap the H and the 3. My inequality is open to the 3, so it still needs to be. H is less than 3. Okay, we're ready to graph. Is 3 less than 3? It's not, so I'm going to use an open circle. My less than numbers, that would be a 2, so I'm going to shade to the left. And that's how you graph inequalities. Thank you for stopping by this Math with Ms. V video.